Understanding clocking in a digital system is as fundamental as understanding gain structure in an analog system. The rules are straightforward. The system may get bigger and have more components, but sticking to the basic principles will make this painless. While several adjustments are permitted, the important thing to know is that by default, Dante handles clocking 100% automatically. If you did nothing to adjust clocking on a Dante system, it'll work perfectly. Only external clocks require any configuration to work. Dante uses IEEE 1588 Precision Time Protocol. Note that this is not Precision Clock Protocol because Dante distributes time. Time is a good thing to distribute as an endpoint can chop up this time into a local clock. So for a 44.1 kHz clock, 1 second will be chopped up into 44,100 divisions, and for a 48 kHz clock, the same second will be chopped into 48,000 divisions. Just like all digital systems, there must be one master in a clock domain, and all other devices should be slaved to that master. This ensures that all digital words can start and end at the same agreed point. If there is no need to define a particular master clock device, which is true in the vast majority of cases, Dante will automatically handle election of the master device. We mentioned how Dante automatically elects a clock from among Dante devices. This is done in accordance with the IEEE 1588 standard. Now we'll talk about how to exercise more control over clocking to suit your needs. Opening the Clock Status tab in Dante Controller, we see two adjustments that we can make. The first is to set a preferred master or masters, and the second is to enable sync to external. What do these settings do? Let's understand the Dante clock election process to find out. Making these adjustments in Dante Controller is easy. Simply open the Clock Status tab to see your present clocking setup and make changes using the preferred master and enable sync to external checkboxes. Next, we'll see how these adjustments affect the outcome of Dante clock elections. To understand this, let's look at how Dante normally elects a clock master. By default, Dante elects a clock without any intervention. This is recommended for most systems. If Enable Sync to External is checked for a device, it will win if no others are designated Preferred Master. If Preferred Master is checked for a device, the device will win the election or compete against other Preferred Masters to win. A couple of notes. If there are multiple Preferred Masters, one will automatically be selected as Clock Master. Configuring externally synced clocks requires interactions with the device itself, not only Dante Controller. Devices using Enable Sync to External should have Preferred Master checked. Remember, this is very often no reason to change the clock election process, unless you are using external clocks to synchronize non-Dante devices that are part of the system. It is usually best to allow Dante to choose a clock master automatically. Why would we make a device a preferred master? In majority of cases, this choice does not need to be made. Dante's automatic clock election process ensures that clocking will work as designed with no user intervention. Even if an election occurs while audio is flowing, there is no interruption. Sometimes users prefer to have a single device always be elected clock master by using the preferred master checkbox. If this option is taken, it makes sense to choose a device that is always in the system by definition. For example, a mixing console is always present and necessary for a live show. It thus makes sense to make the mixing console a preferred master, as without it, there will be no system. If a preferred master goes offline, don't worry, Dante will always elect a new clock master regardless. Note that with software, it is a different picture. Dante Virtual Sound Card cannot provide a clock, while Dante VIA can. Still, hardware clocks are always preferred in elections. You may wish to use the clock that's inside your mixing console, especially if you are using that clock to keep multiple types of digital input-output in sync with each other. Dante supports this, but first you must understand how to properly configure it. In your mixing console, or whatever device you're using as an internal clock, configure the Dante I/O to use the internal clock. In Dante Controller, go to Clock Status and check Enable Sync to External for the mixing console. Also, enable Preferred Master for the mixing console. It is important that both steps be taken. Failure to do so will likely result in clicks and pops, and there will be two independent clocks attempting to run the network. By checking Enable Sync to External, we are telling the Dante system to use the mixing console clock as its source. Use active clock monitoring to ensure that external clock is well behaved. Here are some best practices. When using an external clock, be sure to configure it in both the device and the Dante controller. Always check Preferred Master on the device using Enable Sync to External. You'll know something is wrong with clocking when you hear clicks and pops. And a large percentage of the time, a misconfiguration of Enable Sync to External is at fault. In the vast majority of cases, one should not have multiple devices configured to use Enable Sync to External. There are some rare advanced situations in which this might be advisable, but that is beyond the scope of this course. Dante Controller supports two types of clock monitoring, passive and active. Passive is on all the time and provides alerts when a clock master changes on the network. Active clock monitoring is turned on by selecting it in the Dante Controller menu bar. Active clock monitoring checks to see if the clock master is exhibiting any signs of instability. This can be important when using an external clock, such as that in a mixing console. If you are using the built-in Dante clocks, clock stability will not be a problem. The active monitoring indicator will turn yellow if there is trouble. Click the indicator to open a window displaying clock behaviors over time.